Hello, it's Keith here, and today we're going to be looking at how to create a Hello World example on the Apple II. Now, unlike some of the other systems, the Apple II is going to make things pretty easy for us because it's got a nice firmware that's going to help us out with the basic commands. And in this Hello World series, unlike my main series, we try and use the firmware where available to make things as simple as possible. Anyway, let's go over to the code and have a look at today's example and see it in action. So here's today's code. We're going to be running this. Let's see it right away and just to check it really works. So here it is. You can see Hello World on the screen on the command prompt here. So it does seem to work quite nicely. So how does this example code work? Well, first of all, we need to think about the starting point of our code. You can see we're starting at C00 here. That's the base memory address. This is a very low memory address. It's as low as I think it can get safely, so that's what I'm using. I'm trying to make as much memory available as possible. And you can see we're defining a symbol here. FC62 is the new line command. This is a firmware function. It's helping us out doing the new line. Now, when it comes to the print character routine, we're also using a firmware function, but we're actually making a slight change to the calculations here. This VASM assembler outputs ASCII quite nicely, but unfortunately the Apple II doesn't quite take that ASCII very well. If I just close this running version here and I rem out these two calculations here, I'm adding 128 and then I run again. You can see now we've got some quite confusing gibberish on the screen here, so that's not going to be what we're going to want. So we have to add 128 in this case to get that working properly. So there we go. There's our Hello World running. Now, we're extending this print character into a print string routine here. You can see we're using Y as a counter and 0 page entries 40 and 41 for a 16-bit address. And of course, we're passing it the Hello World string here, which is 255 terminated. We read in each character until we get to the 255, and we pass them all to the print character routine, and that will print our string to the screen, which is what you've seen. You can see it on the screen just up here now. Okay. Now, in my tutorials, I always extend the basic print character routine into a more advanced routine which shows some monitoring functions to the screen. Essentially, when I'm taking on a new system, my first stage is get Hello World onto the screen, and then my next stage is get some simple debugging tools so I can make some progress. And so I've decided to provide those debugging tools to you today because maybe that's going to help you out. So the tools are very simple. A monitor tool, which will show the registers to the screen, and a mem dump tool, which will dump an area of the memory to the screen as well. Now, I'm not going to go into how these actually work. They're a little bit complicated for today, but we are going to see them work. So we can just call this monitor to see all of the registers, or the mem dump to see a memory address and a number of lines on the screen. If I just fire this up now. And you can see that's exactly what it's done. We've got Hello World as before. We've got the A, X and Y registers, the stack pointer, the flags and the program counter, and then we've dumped a memory address just here to the screen. So that's exactly what we might want if we're just starting out and we're needing to do a little bit of debugging. Okay then. So we've seen now how we can just do some simple showing of characters to the screen and how we can do a little bit of debugging. But of course, this is just the source code. To actually get our source code running on a real machine, or an emulator rather, we're going to need to convert that to some kind of binary and then get it onto a disk so we can run it on the machine. And here's the source code for the batch file that I used to run today's example. So let's actually see how this works. Now, the first thing you'll see is we're using VASM here in old style mode, and here's the command line that I used to compile today's example. Now, because it's a batch file, this %1 is actually the source file, so in this case it would be the helloworld.asm file. You can see we're defining a switch CO2. The Apple II actually uses a 65CO2 processor, and so we might want to use some of those extra commands, and so to enable those extra commands we have to use the CO2 switch just here. That will turn them on. We're specifying to check labels. This is a handy little tool because it will check for common mistakes. Now, in our code we might occasionally forget our tab, and the system will mistake that for a label, and that's going to cause a lot of mistakes. So by putting that check labels command in there, it will check if a label has suspiciously the same name as a command, and it will warn us, and that will save some time for us. I'm also disabling case sensitivity because I'm not used to case sensitivity, so it tends to catch me out, so for convenience there. I'm also defining a few symbols. The VASM symbol here isn't really used. I tend to define a symbol with the name of the current assembler, just in case I'm supporting multiple assemblers at some point. And also I'm defining one for the Apple II build AP2 here. That one may be used by the debugger, so I'd suggest you do have that one. If you're using the debugger, you won't need it for the basic one though. I'm outputting a listing file. This is quite handy. A listing file will show the assembly source and the bytecode destination all in one text file. So if you're having weird trouble and you really can't figure out what's going on, it might be worth looking at that. Sometimes you'll find your calculations with your labels might be getting confused because the assembly uses multiple passes, and sometimes you might have caught it out somehow, or sometimes you may not realize how the commands are compiling to bytecode and they may not be doing the same thing as you're expecting. So it can help you if you're really struggling. Now we're specifying to output a binary file with fbin here, and then we're specifying the file name as prog.dot here. And that's the file we're going to need to put onto a disk in just a moment. Now when it comes to creating the disk, I've got a template blank disk just here, so I copy that ready to attach the file to. And then I'm using A2 in here, which is part of the A2 Tools toolkit, and we are specifying that we want to add that. We're specifying a binary file, we're specifying the memory address to start it, which is the same as at the top of my code if you remember. Just here, you can see that. And we are attaching it to the disk file that we just copied up here, and we're specifying the name of the program here. So now we've got a program disk we can actually use. I'm then making a copy of a predefined save state, and then I'm just firing it up with Apple Win, specifying the save state just here, and specifying the disk image that we've created just here into drive 1 here. Now the reason I'm using the save state is just a saving of time really. If you just see my example run here, you can see we've already got brun prog typed in just here. And I mean, it might seem silly to say, you know, save a state with that already typed in. But if you're having problems with your code and it's crashing and you don't know why, you may have to compile and run 20, 30 times. And so typing a few keys, and especially if you mistype and forget the command and type run prog and things, it's going to start eating up time. So anything you can do to get the program assembled and run as fast as possible, I'd suggest you do. So with this assembler, that's just something we can do to save a little bit of time. So there we go. We've learned how to do a very simple Hello World example on the Apple II. If you want to see graphical functions or a wide variety of other functions on the Apple II, please see my other tutorials. There's a playlist on my YouTube channel, and my website's got a lot of Apple II content. So please take a look at that if that's something that interests you. I hope you'll find this interesting. If you want to try these out, please go to my website. The source code for all of my examples are all available for download, and the scripts and tools that I use are also on the website. Anyway, I hope you found this interesting. I hope you'll give it a go, and I hope you'll enjoy programming the Apple II. Anyway, please like and subscribe if you've enjoyed this, because I'll be doing a lot more content coming soon. Thanks for watching today anyway, and goodbye.